Good evening, everyone. I'm Rupert Blackstone, Chair of the Energy, Environment, Sustainability Group at the IMechE. I'm very pleased to be here in Glasgow today, and thank you very much to our host, Glasgow Caledonian University, and very pleased to be working with Andrew and the Glasgow and South West Scotland area group also. Tonight, we've got two speakers, Professor Ian Arbon and Dr. Keith Baker. I will start off with by introducing Ian, who is going to be talking about the energy hierarchy. Keith will then be talking about the 21 for 21 climate actions campaign. Ian was a founder of the Energy, Environment, Sustainability Group. He's been active for many years now, and he's got a wealth of experience, and we focus very much on energy demand reduction as a priority in line with the energy hierarchy. And with that, I'll pass you on to Ian for his presentation. And I'd just to say, please put any questions in the chat box as you go along. We'll be answering questions in relation to each speaker's talk after each session rather than at the end. Just to say, the ladies' toilets are over to that side of the auditorium, the gents over to that side, and please wear a mask at all times when moving around and also when listening. Thank you.
Perfect. Can you just restart the recording?
Right, so there's a restarting the recording there. I'll now pass on to Ian. Thank you, Ian.
Well, thank you, Rupert, and it's a great privilege to be speaking here at Glasgow Caledonian University again. My name's Ian Arbon, and I'm speaking to you this evening on one of my all-time favourite subjects, which is the energy hierarchy, which I think you'll find is very appropriate for COP26. And my credentials are there. I won't say any more about those.
Just click onto the screen, Ian. With this.
Oh, sorry. Yeah. So without further ado, I'm doing something which I rarely do, which is dedicate this talk to someone. And I want to dedicate this to the memory of a good friend and colleague of mine, Sir John Horton, who sadly died of COVID-19 on the 15th of April 2020, one of the first casualties indeed. Sir John was a world-renowned climate scientist, former Director General of the UK Met Office, Chairman of the Royal Commission on Environmental Pollution, most importantly, Chairman of the Scientific Assessment Working Group of the Intergovernmental Panel on Climate Change, IPCC, second and third assessments, which have changed the world's understanding of climate change. And of course, veteran of many COP meetings, and John would certainly have been at this one where he's still with us. I'm very greatly honoured to have worked closely with Sir John and to have had him as a friend and indeed a mentor. I learned a great deal of what I'm presenting today from him. Just by way of a personal introduction, I'm the unusual combination of a career businessman, a chartered engineer, a chartered environmentalist, and a part-time academic. So I address this topic from much more than the viewpoint of a single vested interest. I spent over 50 years in manufacturing industry, mostly in the UK, but also in the Netherlands, Germany, and the USA. I started out my career as an apprentice and worked through many roles in industry before moving into senior corporate management as MD or chairman. First such post being as MD of Howden Compressors Limited, right here in Glasgow in 1987. For most of those 50 years, I have supplied sophisticated engineered equipment into the energy industry, both fossil and renewable. I've actually worked in renewables for over 45 years, long before we knew that's what it was called, around the globe, and know the sector very well. For the past 25 years, through Engineered Solutions, I've focused on delivering truly sustainable solutions in the fields of engineering, energy, and management. We had to talk about IMechE's energy hierarchy. This was first published as a policy statement in 2009 and was revised, updated, and republished in May 2020. The original publication argued that the government's sustainable energy goals were unlikely to be achieved by a focus solely on improvements to supply-side technologies, and that a greater focus was necessary on energy demand reduction and energy efficiency. A decade on, little of this has happened, and goals have not been reached. The energy hierarchy now needs to be implemented if we are to achieve the new 2050 net zero goals. And it will be interesting to see over the next 2 weeks whether COP26 will even recognize this, or will just talk about the same old. Let's start quickly with a definition of sustainability, because this is a term that was more commonly used 10 years ago than it is today, at least correctly, where nowadays we much prefer buzzwords like decarbonisation and carbon emissions and so on. Sustainability embraces all of that, but is much more specific and accurate. So the definition of sustainability that we use in ESG are based on, first of all, the original, the Brundtland Report of 1987, which talks about development that meets the needs of the present without compromising the ability of future generations to meet their own needs. And one I particularly like, the Engineer of the 21st Century inquiry back in 2000, sustainability can best be defined as the capacity for continuance into the long-term future. Sustainability depends upon maintaining and, where possible, increasing our stocks of certain assets so that we manage to live off the income without depleting the capital. Sustainable development is the process by which, over time, we succeed in managing all the different capital flows in our economies on a genuinely sustainable basis. I then want to turn to a definition of energy, and you may think that everybody knows what energy is. Well, I'm sorry to say I still find that many people don't. I heard it misused several times today in reports from COP26, so I'm going to do it. First of all, energy is not the same as electricity. Many people in this country, and even engineers, sadly, seem to confuse the term energy with generation of electricity. In fact, the use of energy for heating buildings and as vehicle transport fuel is far more significant, both in the UK as a whole and in Scotland in particular. It's crucial to any study of energy that we do not create the same confusion. The next thing is that energy is not the same as power. Now, anybody who's done an engineering course knows that, but you'd be surprised how we do confuse them in normal daily life. Generating plant is often described as so many kilowatts, megawatts, gigawatts, i.e. the electrical power rating, but this refers only to the installed capacity, not to how much energy the plant uses or produces. Energy is power used or produced over time and is usually measured in kilowatt hours, which happens to be the unit of electricity that we're familiar with, megawatt hours, gigawatt hours, terawatt hours. And the most important axiom, which I've shared for many years with my students, but is worth repeating, is that energy supply is required only to meet energy demand. Demand must be clearly recognised. Despite this last point being so crucial, the vast majority of people, in my experience, when they think of energy, think first about how it is supplied. In any particular field, they tend to think of their favourite supply technology. Reaching an ambitious target such as net zero greenhouse gas emissions by 2050, while energy demand continues to increase, will be incredibly difficult if we use only existing supply technologies, perhaps with some minor improvements. We will need a game changer, and that, in our view, is likely to be energy demand reduction. I now want to turn to the area that most people miss in all of this, which is global population and energy demand growth. This graph, you've probably seen many like it, shows global population growth from the year dot to the end of this century. And you can see it's really over the 20th and 21st century that we see this exponential rise in population. The question is, does that matter? Well, I think it matters a great deal and should influence everything we do, even though very few people talk about it. This is a graph that I've been using since it was first produced in 1992. And it shows global primary energy demand, that's the large graph, versus population, which is the smaller inset graph, between 1850 and 2100. And people often ask me, well, why do you use such an old graph? Why don't you use something more up to date? And I do that for the simple reason I want to show that even back in 1992, we knew what was going on. We were making very accurate predictions about what was going to happen. And if you look at the population graph, I put in there the population in the year 2000, which was around 6 billion. Then in 2011, we reached 7 billion, and sometime next year, we will reach 8 billion. Now, these become just numbers to us, but this has an enormous significance. And if we look at the energy graph, just to complete that up to date, I haven't updated this very recently, but you find that we're pretty much in the middle of that, perhaps on that B profile of rapidly increasing energy demand globally. So the other major factor in increasing energy demand is global population growth. Almost 2 billion more people on the planet than if we'd started doing what we are now doing in 2000. And I was very struck listening to Boris Johnson's impassioned speech today at COP26 and thinking to myself, that would have been a really, really good speech if we'd given it 20 years ago. But we've missed 20 years, and that's going to prove to be really significant. Most people presented with global population growth of a little over 1% per annum, because that's what it is, appear to be unconcerned. But current growth rates mean that around 10,000 people net, that is births minus deaths, 10,000 more people are added to the planet's population every single hour of every single day. And every one of them is a new energy consumer and a greenhouse gas emitter. Of course, there are no easy or ethical answers to the population growth issue, but is it ethical to continue to ignore it? I think not. So, looking at the UK's international energy security, contrary to popular belief, this was taken from UK Energy in Brief in 2019, contrary to popular belief, the UK is nowhere near self-sufficiency in energy terms and has been a net importer of energy for most of the past half century. This situation is likely to continue for the foreseeable future, so our ability to import energy to meet our demands is crucial. Despite this, The mistaken belief that the UK is still largely self-sufficient in energy provision has formed the backbone of UK energy policy for many years and continues to do so. This mistaken belief and consequent absence of long-term strategy, especially in the reliance on spot pricing for fuels, has been a major contributor to the recent crises with vehicle fuel supplies and currently with the major escalation in natural gas pricing. Not a lot of people talk about it in that way, but I can assure you that is so. Fuel price volatility is another major reason why a focus on energy demand reduction will lead to a much more sustainable future for UK energy policy. So I just want to look at UK energy consumption. This was a graph I drew at least 12 years ago, it says, just showing a lot of people still don't understand this. The UK's energy split, if you look at the numbers at the top of the graph, energy for transport is around a third. Heat energy is around just a little over 40%. In fact, it's a little over 50% in Scotland alone. And electric power is just a little over a quarter. So you can understand the problem if we don't clearly distinguish between electricity and energy. Most of the energy we use is not electricity. That 15% marker was our target as overall energy for the UK in 2020, and we missed it. This graph I could spend a long time on, and I can't afford to tonight because I don't have the time, but it just shows actual GB energy demands, GB because it doesn't include Northern Ireland, in gigawatt hours per day from 2010 to 2021. And it's a fascinating graph. It's produced by a colleague of Rupert and mine called Grant Wilson, Dr. Grant Wilson at the University of Birmingham. Grant is a Glaswegian, and he produces these charts, and we use them all the time. But I just wanted to quickly show the blue line is heating demand. The black step line is our vehicle fuel demand. And the red wiggly line is our electricity demand. And that's all green is so-called electricity from low carbon sources. We'll ignore that for the moment. And what I wanted to show you on that is that if you look at the 2020, so near to the right of the chart, you will see how much energy demand was down in 2020 for heating and for electricity. And look at that spectacular reduction for vehicle fuel. And that is simply because we stopped going places. That is energy demand reduction. We've done it because it was forced upon us. But think about the impact that could have if we chose to do that. This chart's been used by government, came from Dukes, to demonstrate that UK energy consumption has been falling over the past few years, which of course is seen as a desirable outcome. And I would agree if there wasn't something hidden in there. It disguises the fact that transport energy consumption has risen dramatically and that the huge reduction in industrial energy usage over the period is simply explained away as deindustrialization. This benign sounding deindustrialization, supposedly reducing UK industrial energy demand from 43% to 17%, is perhaps better explained by the offshoring of much of the UK's former manufacturing sector to developing countries, along with its related energy demand, costs, and greenhouse gas emissions. This was demonstrated in a 2019 Office for National Statistics report showing Britain to be the biggest net importer of CO2 emissions in the G7. I didn't hear that in the Prime Minister's speech today. So the UK benefits from lower cost of production, but expects other countries to account for all of the associated greenhouse gas emissions. No wonder that we've managed to reduce them. Furthermore, the huge increase in transport energy consumption since 1970 still does not include either international aviation or shipping, each of which sectors is now responsible for approximately 2% of global greenhouse gas emissions. So coming at last, you'll be relieved to hear, to the energy hierarchy. You see a copy of the original version on the left there. The concept of an energy hierarchy was first developed within IMechE in the early 2000s and publicly launched at ICOMIS in Brussels in 2007. Following widespread endorsement from other international engineering institutions, it was published as an IMechE policy statement in 2009. The 2009 publication, this is the 2020 version on the left, argued that the government's sustainable energy goals were unlikely to be achieved by a focus solely on improvements, to supply-side technologies, and that a greater focus was necessary on energy demand reduction, energy efficiency, and behavior change. A decade on, little of this had happened, and goals had not been reached, as I said before. The energy hierarchy was updated and relaunched, and now needs to be implemented. This is just a quick overview of the diagram showing the energy hierarchy, which I'll explain in more detail in just a moment. But it's a simple concept with profound outcomes. The energy hierarchy follows the rule that a kilowatt or kilowatt hour saved is more valuable than a kilowatt or kilowatt hour produced, no matter by what means. We get so hung up on the means of production that not using that kilowatt is much more valuable. Similarly, the higher up the hierarchy we go, that's the blue arrow on the left, the more sustainable the process is. Now, how the energy hierarchy works: Tier 1, energy demand reduction, simply do not use as much energy. Then Tier 2, energy efficiency, find more efficient ways of supplying and using energy. 3, renewable, sustainable energy resources, those with the least environmental impact. 4th, other low greenhouse gas emitting energy resources. And 5th, conventional energy resources, or the way we currently do it, and we still do by and large. The first tier of the hierarchy, energy demand reduction, is a demand side measure which often requires lifestyle change, but has the greatest, quickest impact on demand reduction and greenhouse gas emissions. It should be obvious that a greater impact can be made by saving a kilowatt or a kilowatt hour of energy and finding a better, cleaner way of producing a kilowatt or kilowatt hour of energy. This concept is also known as the negawatt, a term coined by Amory Lovins of the Rocky Mountain Institute in 1990, or as he called it, the what you don't use. General examples of this are using all forms of motorized transport less, insulating buildings better, passive solar and low emissions building design, turning thermostats down, avoiding travel by holding virtual meetings and conferences, etc. The key component here is sustainable action, which for most of us will require behavior change. Before COVID-19, this was considered almost impossible to implement in developed societies such as in Europe, yet now we can all see the benefits, particularly environmental, that have ensued. Energy demand reduction, the first tier, is not the same thing as energy efficiency, second tier, despite government's continual confusion of the two, which probably explains why so little has been achieved in the UK over the past few decades compared with other developed countries. The classic example of this distinction is in the lack of thermal insulation of buildings in the UK, which is generally described as an energy efficiency measure when its main function is clearly to reduce the amount of energy supplied. And I'm hoping Keith will be touching on that later in his presentation too. A few years ago, and this was an amazing statistic to me, it was noted that people in the UK paid about half as much per unit of energy as people in Sweden did. But their annual energy bills, our annual energy bills, were twice as high as those in Sweden. That's because of insulation. We may deplore the tactics of Insulate Britain, but they are correct that this is the single most important step that we can take towards net zero emissions. Retrofitting new expensive supply-side technologies will not achieve this. Something we need to bear in mind, whether we're talking about heat pumps or hydrogen, about which everybody is talking nowadays, that if you put those into uninsulated buildings, you will have problems. As recently as May 2019, the UK's Committee for Climate Change was claiming that their newly set targets for net zero could be achieved largely using existing technologies and had little to say about the role of behaviour change. Then in August 2020, the CCC revised its views and stated that the targets would be achieved by a combination of behaviour change and technology, which we'd realised from the beginning. In April 2021, the Cambridge Sustainability Commission, in its new report, Changing Our Ways, Behaviour Change and the Climate Crisis, stated the goals of the Paris Agreement on climate change cannot be achieved, their words, cannot be achieved without radical changes to lifestyles and shifts in behaviour, especially among the wealthiest members of society. It says the world's wealthiest 1% produce double the combined greenhouse gas emissions of the poorest 50%, according to the UN. The wealthiest 5% alone, the so-called polluter elite, contributed 37% of emissions growth between 1990 and 2015. The second tier of the hierarchy, energy efficiency, is both a demand and a supply side issue. On the demand side, this requires the use of low energy appliances and lighting, highly efficient space heating, cooling devices, micro CHP, hybrid and low fuel consumption vehicles. On the supply side, this involves making much better use of energy input to energy output ratios, otherwise known as energy productivity, fully integrated systems such as combined heat and power, district heating schemes supplied from electricity generating plant, waste heat recovery systems, etc. Those concepts must be promoted by governments and large corporations. There is still plenty of opportunity for individual behaviour change to make an impact. Care must also be exercised to avoid Jevons paradox, a feature from the 19th century, that increasing energy efficiency may simply lead to greater energy consumption. All this a danger. The third tier, renewable sustainable energy, is a supply side measure involving the use of fuels which have the lowest overall, that's whole life cycle environmental impact, and which meet the other sustainability criteria, economic and societal. Almost all renewable forms of energy can also be considered to be sustainable, although care must be exercised, for example, with large-scale hydroelectric schemes. Biomass and other biofuels are also important renewable fuels, but require careful whole life cycle analysis to ensure sustainability. It's vital to achieve net zero greenhouse gas emissions that development continues in this tier, but care must be taken to ensure the achievement of the first two tiers is prioritised so that the targets to be achieved are not continually growing. Fourth tier, using other low greenhouse gas emitting energy resources, is another supply side measure which includes other energy supply technologies which achieve reductions in overall life cycle greenhouse gas emissions. This can include thermal power generation from cleaner hydrocarbons, for instance, or nuclear, although these have other environmental and societal issues which have to be addressed in a sustainability analysis. Although the current UK practice of gratuitously wasting the co-generated heat energy from power stations must cease, that is just bad engineering. Lower carbon content vehicle fuels will also significantly cut down greenhouse gas emissions, but may well have other sustainability issues. Hydrogen as an energy vector may also be included here, although it also has significant sustainability issues which must be addressed. And I say that from the background of being someone who has spent over 50 years in hydrogen compression, and I know a bit about the subject. If the first 4 tiers can be successfully implemented, then it follows that the 5th tier, doing what we currently still do, but perhaps a little bit better, need never take place. And existing forms of power generation, space heating of buildings, and fueling of motor vehicles can eventually be phased out. This also means that continued exploitation of finite reserves, especially fossil fuels, will decline and will become much less of a strategic issue. And then I give you a link to the energy hierarchy where you can download it from the IMechE website. The conclusions and recommendations are the conclusion and recommendations in the paper, so I will skip those in view of time and continue with a way forward for net zero. For the past 200 years or so, the aftermath of the Industrial Revolution, the UK, along with many other countries, has had a policy of trying to reach strategic energy objectives by focusing almost exclusively on supply-side technologies. Unlike most other Northern European countries, little thought has ever been given to reducing energy demand to make energy supply objectives more readily achievable. Since 1990, when the first IPCC assessment started to make us all aware of the need to mitigate and/or adapt to climate change, the UK's energy goals and targets have become increasingly more based on sustainability goals. Despite this, the proposed methodology of achieving these goals has remained firmly with a greener, cleaner supply side, and we'll hear lots about that at this conference. Making efforts to reduce energy demand has not met with any success. Consequently, the UK's 10% renewable electricity by 2010 target was not achieved. The 10% renewable transport energy and 12% renewable heat energy by 2020 targets were also badly missed. Yet, despite this poor track record, virtually all of the measures that are being proposed to achieve the 2050 net zero greenhouse gas emissions are also supply-side technologies, with only slight improvements over what has gone before. This does not augur well. To paraphrase G.K. Chesterton, it is not that energy demand reduction has been tried and found wanting. It has been found difficult and left untried. This is because a prerequisite of energy demand reduction is human behavior change. Unless each of us changes the way we live, we will go on trying to consume more and more energy. Many years of lecturing on this subject, I've been fairly consistently told that human behavior change is just too difficult for people in the developed world to embrace. However, the present COVID-19 crisis has changed all of that. Behavior change has been forced upon us, and the results have been amazing. Energy consumption in the UK was down to, in 2020, was down to levels not seen since the 1960s. Globally, climate scientists are saying that 2020 will see the lowest recorded greenhouse gas emissions in decades. If nothing else positive comes out of this terrible pandemic, let's make sure that the new normal after this crisis is finally over does not simply revert to our old energy wasteful ways. Following the principles of the energy hierarchy will help us to ensure that our world will indeed be a cleaner, greener place for our children and grandchildren. Following quotation is apt. Humankind is challenged as it has never been challenged before to prove its maturity and its mastery, not of nature, but of itself. That was a quotation from Rachel Carson's Silent Spring in 1962, which virtually launched the environmental movement. So if we're serious about achieving the goal of net zero greenhouse gas emissions by 2050, it will require behavior change. We cannot rely solely on supply-side technologies. The principles of the energy hierarchy are commended to you. Thank you very much for your attention. I'm sure there will be some questions.
Thank you very much indeed, Ian, for that excellent presentation. I've heard Ian speak a number of times on the energy hierarchy, and we've discussed it many times over the years, but each time I learn something new and look at it in a different way. And Ian always gives a slightly different angle, and it really brings home that we just can't go on relying on technological solutions, much as engineers we're very enthusiastic about technology. Behaviour change is such a major aspect of what we need to do to face our challenges and solve the problems. So now I'm going to invite everyone from the floor and online to ask questions. Andrew's going to go through the questions online, and I'll sit with Ian. We'll switch to the table and look forward to your questions.
I've noticed a few people using the chat area for questions. If you could just make sure you put them into the Q&A area, just to make things a little bit easier at this end, if that's okay. But I will go through the first question here in the chat area. So Thibault Sam, thanks very much for your question. To Ian, is the need for energy demand reduction being ignored by policymakers, or are they not aware of its significance?
Good question, Thibault. It's a combination of both. I think it comes about from having confused energy demand reduction and energy efficiency. And anything you see from government, and not just the UK government, but other governments too, it talks about energy efficiency, and it doesn't separate out energy demand reduction. And to us, in the energy hierarchy, they are two quite distinct areas, and you must do both, not ignore the first one, which is what tends to happen.
Thank you. Our next question is from Frank S. What is the driver behind our apparent inadequate political leadership that is failing to confront behavioural changes raised 20 years ago? I'm sure you'll have an answer for that.
If only I had an answer to that. It staggers me because I thought the Prime Minister's speech today would have been really excellent if it had been given 20 years ago. Because we were all, most of us anyway, were sleeping on this subject 20 years ago, we've missed that whole opportunity. And there are now 2 billion more people on the planet. So the problem, the mountain we have to climb, is now much higher.
Thank you. I don't seem to have any more questions online just at the minute. Any questions from the room? Yes, thank you.
Thank you very much for that, Ian. The behaviour change that you say will be so necessary, and I agree with that. What do you think is going to drive it? Do you think it's financial? Do you think it's laws? Do you think it's engineering to make it easy for people? Do you think altruism is enough? What do you think we need to make people behave differently?
Yeah, again,
so can I interrupt? Just in case the online audience can't hear the question, would you mind summarising that? Oh, sorry, the question. Yes, I'll take the microphone.
Thank you. To repeat, can you hear me? Okay.
yes.
Ian has explained how necessary behaviour changes, and I completely agree. What does he think are the drivers that are going to make it happen? Altruism, financial incentives, engineering, making it easy and attractive, or does government need to legislate and force people to make some of these changes?
Well, as always, I think it's a combination of all of these things. government legislating for it is going to be difficult because that would presuppose that the government understood the problem in the first place, which it hasn't shown any signs of doing so far. I become increasingly convinced, that the government doesn't see the real need for behaviour change. They keep assuring us that we can continue to fly as much as we did and travel as much as we did, which is clearly not the case if we're going to achieve the targets. Multinational corporations, oil and gas companies and so on have very clear vested interests in why they don't want to see this level of behaviour change. And as a businessman, I can understand that, but it doesn't make it right. So I'm becoming increasingly convinced that it has to come from a groundswell of public opinion. And if the protesters out there in Glasgow could win over the public rather than simply antagonize many of them, I think we could convince ordinary people like us to make a change. Then I think we would see remarkable things happening. But that I fully confess is not going to be easy.
Okay. Yes, got a question from the room.
Hi, can you hear me? Yeah. Thanks very much for the talk. It's fascinating. For me, just maybe developing the question that was just asked about what might help. For my perception, part of the problem is an obsession with constant growth and financial institutions and businesses and governments are driven by that. And I wonder if there are different models that would offer a kind of more positive way to design economies. I'd be interested to hear your thoughts and alternatives that might help a better future.
Yes, I think you put your finger on the biggest single stumbling block on all of this, because we do live in what is by and large a capitalist world driven by capitalist ideology, and everything is measured in terms of GDP, and there are. It would be simplistic to say that there is an easy solution to that. If there were one, I think I would have made my fortune by trying it out over the past 20 years. But I remain convinced that unless we break free from the GDP growth model, we will not achieve all that we're trying to achieve. And I think this is going to prove to be one of the major stumbling blocks of COP26, because there are just too many vested interests out there that seriously do not want to change that. And it's very difficult to know how we can do that from the bottom up, because it's always been a top-down approach. It's an excellent point, and you've put your finger on another problem.
Thank you, Ian. I've just got one more question from online, if that's right, before I hand over to our next speaker. A question here from Ted Cooper. During the government's management of the COVID crisis, there was much display of taking on board health specialist input. Is there any chance that our engineering specialists will be given more direct input towards achieving the 2050 target?
Well, excellent question again. Based on our experience so far, I would say no chance, because I think we as engineers have been trying to get the ear of government for the past 25 years, to my knowledge, and it's never been received. But I think one of the interesting things things is that engineering and science are two parts of STEM, and it would, in the COVID crisis, we turned to health professionals, scientists, because we had to look to the science. And the same is absolutely true in terms of climate change mitigation. We have to look to the science. And I know I met many scientists through Sir John Horton who could explain the problem really, really well. But scientists aren't the people who, by and large, who are going to find the solutions. Engineers are. That's how we complement each other. I think until government, particularly the UK government, because it's been notoriously bad at it for the past century, take views engineers in the same light as it views scientists, I don't think we can solve this problem.
Okay, thank you, Ian. Rupert, would you like to come and introduce our next speaker?
Thank you very much, Jim.
Thank you.
And thank you everyone for the great questions. I'm now going to introduce Dr. Keith Baker, who is a researcher here at Glasgow Caledonian University in Beam, and he's co-founder of the Energy Poverty Research Initiative and also a member of the Common Wheel Energy Working Group. And Keith is going to talk about the 21 for 21 Climate Actions campaign. So over to you, Keith. Over to you, Keith. Thank you.
Hi, everyone. Nice to see a hybrid conference going on. I'm going to get to that in a bit. Thanks to the IMechE for inviting me, and thanks to Ian for a great introductory talk that's set this off on a nicely political start, and I might be going further on that. Just to give you a little bit of a background, I'm a researcher in energy poverty and fuel poverty, fuel poverty and energy policy at the Built Environment Asset Management Centre here at GCU. And then back in 2017, me and a couple of colleagues who I've been working with for years decided to set up this little initiative, EPRI, for a bit of a collective identity, recognising work we've been doing together for 10 plus years. Then in 2018, really, really impressed with the work that Common Wheel does. For those of you who don't know, Common Wheel, it calls itself a think and do tank. More than a think tank, we actually go about trying to get these changes into action, into government policy. So we hammered on their door for about 6 months, then eventually got in, and that led to the formation of the Energy Working Group. And then in 2019, GCU recognised EPRI as a spin out from the Beam Centre. So that's got us where we are. A little bit of good news in recent weeks, as you may have seen from the biog. As a result of the work we've been doing, I've become a fellow of the Royal Society of Arts. So we've got a bit of a confluence of professional associations going on. It's really good to see engineers getting involved as well, because as Ian was saying, you know, scientists provide the science, the engineers provide the, you know, work out how we're going to do it and what we're going to do. And then I suppose the likes of me, I'm an environmental scientist by background, PhD in domestic energy consumption, which is buildings. And I do engage in the dark arts of lobbying. And I've learned a lot over the last few years working with people like Robin McAlpine and Craig Deal. So I think, given it's the first day of the COP today, it's worth remembering that the UN Secretary General said today that that no country's goals or commitments are going to set us on a path to limiting global emissions, global average temperature rise to 1.5 degrees C, which the science tells us is the safe limit. The UN report last week saying it looks like we're on track to reach about 2.7 degrees C. And that's, as a scientist, that's getting into scary territory. I've been a reviewer on both the last working group 3 reports for the IPCC. And I'm one of these people, you know, you get involved in the process and you're sat on this really, really authoritative, in some cases quite scary document, and I'm not allowed to say a word about it. Working Group 3 is due to be published in March next year, and again, I wish I could say stuff, but I can't. Needless to say, if you saw what came in Working Group 1, then be prepared. So a little bit of background. I'm here to talk about the 21 for 21 campaign. This is a statement that Commonweal and EPRI and GCU co-launched back in July to coincide with the launch of the Working Group 1 report. It came about because we were approached by a group of, by an MP, Douglas Chapman, and his team. Douglas happens to be my local MP. They'd seen the work that we've done. Commonweal in the past, please do check out their website. We've published things like the Common Home Plan, which is a fully costed Green New Deal for Scotland to totally transform Scotland and decarbonise us by 2045 without critically leaving anybody behind. There's been an update to that since COVID hit. We've got the Resilient Scotland Plan in parts 1, 2, and 3. To put the politics on the table, we are largely a pro-independence organisation, but we do work across all political parties. Douglas happens to be in the SNP, but I'm going to make some criticism of the SNP. I'm going to be a bit of an equal opportunity offender. We don't have a strong party. Well, we don't have a political party point of view. We will work with anybody. In fact, most recently, I've been doing a lot of work with Monica Lennon and MSP on the case for a public energy company. That's something that Commonweal first proposed back in 2014. I don't think we were the first to propose it, in fairness. It's been put out as a government commitment by Nicola Sturgeon twice now, and it's twice been reneged on. So Monica is busy working to try and get that back on the agenda. So in terms of 21 for 21, I've been asked to, because there's no way I can get through 21 different points. So before we had, when we were preparing this event, we had a bit of a chat, and I think we pulled out about 5 things to talk to. So action 5 is leave no one without a warm home. Action 13 is make energy efficiency meaningful. Action 14 is measure the whole life energy of homes. Action 11 is a train a renewables workforce, and action 17, I was asked to put this one in because it seems to be a bit controversial, but instituting a legal right to home working, following on nicely from what Ian was saying about the changes that we've seen post-COVID. So to get the first one out of the way, leaving nobody without a warm home, this is my field, or my core field. At the moment, about 1 in 4 households in Scotland are classified as being in fuel poverty, and about 1 in 10 are classified as being in extreme fuel poverty. That means that we have a sizable proportion of the population who cannot afford to live in warm, comfortable homes for a reasonable cost of energy. That is absolutely shocking. The fact that in a modern democratic society we have 1/4 of people who can't basically afford to heat their homes, who are left with choices. We talk about heat or eat, left with a choice to either keep a warm home or to put food on the table for their kids. This is one of the reasons we set EPRI up. Fuel poverty is a complex problem. It has a technical component. There are some technical solutions to it, but actually a lot of the problems that the fuel poor householders that we deal with are facing are actually really social problems and economic problems. The Scottish Government has a mantra, and you've probably heard this, of fabric first, thinking that we can solve fuel poverty just by increasing the energy efficiency of our homes. And the next point I'm going to make under energy efficient homes is going to say, well, actually, we're not doing a very good job of that either. But what we're not doing a good job of is understanding the complex needs of fuel poor householders. These are, I can quote multiple papers that we've written of examples of people who have anything from people going through difficult life experiences to people for whom English isn't the first language, through to people who simply don't understand their energy bills. We published a paper a couple of years ago where we looked at over 7,000 homes in Renfrewshire, and we've got an awful lot of data on these. And actually, the most common thing that people sought advice for was how to use their heating systems. And that is simply a matter of getting qualified, or in this case, not hugely qualified people actually into a person's home, and giving them a simple demonstration. It can be life-changing for them. Certainly support organisations, local authorities, housing associations, Citizens Advice Bureau, and wonderful organisations like Southsea, who are a community-based energy support organisation just based down in the south side of Glasgow, who do this work, and they do it with very little recognition. People like to blame local authorities for things. They like to blame housing associations for things, but actually, a lot of these organisations are understaffed, under-resourced, and they have an incredible amount of responsibility placed on them by the Scottish Government, which seems to think that if you tell a local authority that it needs to deliver X, Y, and Z, it will be able to go ahead and deliver it. So this is a significant change that we need to make, and we need to get this into the head of policymakers as well. Policymakers like going for simple solutions. One of the reasons we have so many wind farms in Scotland is because it's easy to design policy to stick up wind farms. It's much harder to design policy to implement effective district heating systems, sort of 4th and 5th generation systems that we see in Denmark and Scandinavia generally, in the Netherlands. We've just had the Heat Networks Act go through, and as part of that, I was part of a workshop with a group of civil servants, and one of them said, well, actually, this is based on no data. And one of the things that we have consistently and clearly argued for, going back for me well over 10 years, is that we need to be basing policy on real data. And that might come as a shock to some of you who think, well, surely there's data going in there. And actually, in many cases, it's not. We base a lot of policy on proxies, assumptions, thinking we know stuff that actually, once you start asking questions, you think, actually, we don't know a lot of this. And that brings me on nicely to my second point. And I could give a talk on EPCs that could be 15 minutes, half an hour, an hour and a half, 2 hours. As I say, my PhD is actually in domestic energy consumption. So, this is what I've spent a lot of time working on. To put it very, very bluntly, and you guys, if you're from the institution, will probably be aware of this, that energy performance certificates, as we know, are not worth the paper they are written on. The model behind what we know as an EPC is BREEDEM, the Buildings Research Establishment Domestic Energy Model, currently in version 12. That model itself is based on a survey of 53 more efficient buildings in Milton Keynes in the early 80s. I'm not going to criticize the model too much because we do need a model for new build, but that model has never really been validated. The attempts that have been made have been made on largely homogeneous groups of properties. It has improved a lot over the years, but it is still a million miles away from calculating accurately, an energy consumption of a home with a household in it. And as Ian referred to, human behaviour, a lot of the error in that does come from human behaviour. We can look at studies of domestic energy consumption, mine and others, and we see a very, very clear and strong relationship with the total floor area of a property. That will explain, with a very, very high degree of statistical significance, about 60%, maybe 65% of the variation in energy consumption between properties. It goes down to about 40% for flats because you have heat sharing and the various conditions that flats differ from houses. And the rest of that, 35%, is a mix of all sorts of things. It can, of which human behaviour will be a significant part. We looked at for a paper we did for a policy paper we did with Commonweal on carbon-free, poverty-free, funded, but with no conditions by CALA. We looked at a relationship between fuel poverty and things like insulation and education, income. And generally, you don't necessarily find that the technical indicators are the strongest. Education actually came out really quite strongly, which when you think about it, if you don't understand your heating system and you don't understand your energy bills, it's the sort of thing you would actually expect. And the data does bear it out. Getting proper data is a big problem. As part of my PhD, I was the first person in the UK to access annual energy consumption data for a couple of groups amounting to about 250 homes in Leicester and Sheffield. Now, that was annual consumption data, but it was real data, and we can do a lot with it. The problem is with EPCs that we don't put an awful lot of real data in. Now, I mentioned BREED M12. BREED M12 sits behind SAP, the Standard Assessment Procedure, which is the tool. But unfortunately, for most building surveys, if you've been to sell your home or buy a property, your EPC may well be based on a reduced data set Standard Assessment Procedure assessment. If you've ever done a home energy check, the sort of things that your energy advice organisations throw out, really quite limited amounts of data or information, I dare not call it data really, plugged into a model which comes out, via running through a whole load of assumptions and proxies, and this is roughly what you should be spending on your energy, and these are the improvements that you should be doing, that you should be making. We could go on at length about the recommendations that will come out of an EPC and how realistic they are or not. Just based on my last property, I had a building surveyor come in, qualified, chartered, but she looked at the walls and assumed I had a fillable cavity, to which I pointed out that actually where the vents were showed that it wasn't a fillable cavity, and I volunteered to tell her where in the model that she needed to make the adjustments, and that didn't go down very well. But EPCs remain our primary measure of home energy consumption, and they are a key tool for driving and dictating policy. So you have to ask yourselves, why, given that there are decades of papers and research by, some of the really, really good building scientists, why we are continuing to use what is, I don't even want to call it data, I don't want to call it information, a label which is totally unfit for purpose. And after years and years of sort of me and Ron Mould, one of my co-founders, going around speaking at events and saying, well, EPCs are crap, we thought, okay, well, whenever we say this, people come back to us and ask, well, okay, if not an EPC, what should we use? So back in 2018, we published our first policy paper for Commonweal energy performance certificates, an alternative approach. And as part of that, we looked at the Energy Performance of Buildings Directive, which is the overarching EU directive. It's good, the guidance is good. Okay, we may not be currently in the European Union, but it is Scottish Government policy to maintain alignment as much as possible. So we looked at what EPBD says, and we looked at all the various research that we and others have done, and we came up with a set of alternative proposals. Key to that was making more and better use of real data. That finding made its way into the academic panel review of the fuel poverty definition back in 2018, 2019. It was a finding rejected by the Scottish Government. We currently have the consultation's actually just closed, but the Scottish Government is consulting on reforming EPCs. We know through our contacts with the government that there are certain things that we put into our paper, like contextual data, adding to an EPC. So for contextual data, it's simply providing a householder with suitably anonymized information on the people that are selling the house or previous tenants, just so that, say you're a young family moving into a new property and you're buying from, say, I don't know, an elderly couple or something, that whatever you're getting for your energy consumption is likely to vary according to the differences in your personal circumstances. It's not ideal, but it's the sort of thing you could add quite easily to an EPC, and we've been told that they may be minded to recommend that. But one of the things they're not going to do, and we've been told this quite explicitly, is a move towards using real data. Even as far as what we're now saying is, well, why, if you're selling a property, why can't you call up your, or as part of generating an EPC, you call up your energy company and say, please, can I have my last year's energy data? And I will submit that to my building surveyor, and that forms part of an EPC. Now, I could go into a long history of things like our review of the energy performance certificate, sorry, my review of the energy assistance package and all the problems we had there. And that's available from our website. We've just published an evidence document. This goes back to some work I did for the Scottish Government in 2012, 2014. And one of the conclusions of that report was that one organisation in particular, and I'm going to name them and say the Energy Saving Trust, was lobbying the government hard to deliver, to design schemes that it is good at, that it can deliver. The Energy Saving Trust is our big bête noire, along with its partners, Changeworks, Everwarm. Those three form Warmer Home Scotland, and they make quite a lot of money out of delivering EPCs as they stand. They are a private company. They're a not-for-profit company, but they are still a private company. And one of the things that we found, as I found as part of this review, was all the other stakeholders who I spoke to, which 14 different stakeholders, 18 different people, was that the EST had been lobbying the Scottish Government really quite hard to deliver, to design programs, which, funnily enough, it was capable of delivering. Now, you guys are sat there with your various proper technical qualifications. But if you're going out and delivering an EPC in the field, particularly things like home energy checks and things, if you're doing it as part of buying or selling a house, then you are supposed to employ a chartered surveyor. But a lot of the home energy checks that we use are delivered by people with probably at best a city and guilds in energy awareness. I'm a building scientist. A lot of my knowledge and experience comes from, partly my academic training, but partly my practical experience. If you have a city and guilds in energy awareness, it's reasonable for you to go into somebody's home and say, oh, you need to, you could improve your installation, you could do a few things, but you will not get the technical or the proper technical standard of advice unless you employ a appropriately qualified professional. So it begs the question of, why are we actually doing this in the first place? Given that if you are in Scotland, there is a greater than 50% chance that your property is going to need some level of significant repair to critical elements. You can check all this data in the Scottish House Condition Survey. Why are we employing, for want of a better word, effectively a substandard method delivered by inappropriately or insufficiently qualified and trained people? And I will come back to that in a minute when I talk about training workforce. But there are big political elements to this, and we have to be realistic. There's the COP going on, just down the road from you guys at the moment. That is a heavily politicized process. I'm just going to check the time because I could go on about EPCs at length, and I don't want to let them dominate the conversation. But really, this is something that we as scientists and engineers have to lobby hard on, because we fundamentally believe that if we do not tackle this issue of using real data, then we are not going to solve our energy efficiency problems, we're not going to solve our fuel poverty problems, and we are ultimately not going to solve this big problem of climate change. So I'm just conscious of time because I've only got half an hour for this. But moving on, another thing that we put into 21 for 21 was measuring the whole life energy of houses. Another thing I've done a lot of work on with GCU in the past is sustainable building materials. How we design and deliver better quality, more comfortable, not just more energy efficient, but more comfortable properties. And again, this is something that Commonwealth's been lobbying on a lot, and I've been lobbying on. Why have we reached the stage of being now in 2021, almost 2022, and we are not looking at the whole life costs of houses and other buildings that we procure? Because the money comes from somewhere. Some of it comes from public funds, some of it comes from our own pockets. Why are we not looking at the whole life costs? Operational energy is only one part of the life cycle of a property, or anything else for that matter. We can do it. Carbon accounting now has been around for a long time. It's an imperfect science, if you want to call it a science. It's probably more of an applied science. But we have a lot of data on the embodied energy of materials. We can, with reasonable degrees of accuracy, sort of actually certainly get from the point of materials extraction through to people occupying a property. End of life is interesting because different materials will be treated in different ways once a building is earmarked for demolition or changing purpose or whatever. Wood's a good fun one. We can typically assume standard lifetimes for materials, but wood, as we know, it's a cracking building material, and it sequesters carbon, and it will be often around for a long time after it's been used in a building. Bits of the building may be repurposed, and even if it ends up buried in the ground, it's still sequestering carbon. We really need to be moving towards a point where our homes are 99%, 100%, 99% recyclable and biodegradable. And actually, there are companies in Scotland doing that right now and have been doing it for a while. The work that I did with the Natural Energy Efficiency and Sustainability Project at GCU, fantastic company up in Inverness, IMechE, run by a guy called Neil Sutherland. Initially started off as an architect's practice, employing himself and 2 other people. Now employs over 30 people, including apprentices, in the Inverness area. You guys may well know that a part of the problem we have in Scotland, or one of the many problems we have, is that if you are a young professional training up in the north, the chances are you will see the bright lights down in the central belt, or perhaps down in London, and the money. Because this is where the capital is, and they move south. And not only do you lose those people's skills from their local communities, but obviously you lose that you lose the money that they earn that gets paid back into those local economies. So it's contributing to economic deprivation in rural and island areas. And moving back just briefly on fuel poverty, this is an ongoing problem. The fact that rural areas and island areas are suffering quite significant amounts of economic and social deprivation. And if you look at the Scottish Government statistics, or at least the statistics before 2019, when the fuel poverty definition was changed, they were misrepresenting the extent of what we would term the energy spend gap between urban and rural and island householders. It is significant. The official statistics acknowledged it. Our research, using real actual energy consumption data, showed that not only was this divide much more, or is much more significant than official statistics show, but also the measure of income that we were using, the income domain of the Scottish indices of multiple deprivation. We argued, along with the team at Loughborough, that this was not fit for purpose. Now, one of the only successes we've had, I suppose, in our annoying the government, was that as part of the current fuel poverty definition, we are moving to a measure of income based on the minimum income standard approach, which is developed and run by Loughborough and the Joseph Rowntree Foundation. And as a result of our work, we've also got into that act a financial uplift for householders in rural and island areas. Now, the fuel poverty strategy is not out yet, but we are led to believe that there will be some form of financial aid or financial adjustment for those householders. The fuel poverty strategy has been delayed by about a year now. The government is looking at COVID and saying, hey, that's a good excuse, but it is due out shortly and we will be issuing a response when it comes out. Which brings us nicely back to a response I've had from Michael Matheson in the last couple of days. With 21 for 21, we pushed out, or we emailed all the party leaders, say we're going to be equal opportunity offenders on this. So far, the only parties we've heard back from are the SNP and the Independence for Scotland Party. Scottish Labour, the Lib Dems, the Greens, and Alba have not replied. Alba's an interesting one because they did largely adopt Commonwealth's policies, and they are a smaller party, so maybe a bit tied for resources, but we've not heard back from, as I say, Labour, and the Conservatives, the Liberal Democrats, or the Greens, which is in the latter case, is particularly annoying given that we now have Patrick Harvey as the junior minister for decarbonising housing. On that question of will we include whole life energy costs, the reply from Michael Matheson, the minister, is that the Scottish Government currently has no plans to do so. Again, this is something we could and should be doing really quite easily. You know, it involves getting support, getting the right technical people in place. In fact, getting technically trained people into the civil service. I spend a lot of time dealing with civil servants, and you know, when you do that, it rapidly becomes clear that the technical knowledge within the civil service is severely lacking. A lot of, I would say most, probably a lot of civil servants come from social science or political science or economics backgrounds, and they do not have that technical knowledge. And one of the things that, one of the other things in the 21 for 21 list is establishing a Scottish Energy Development Agency. Now, the primary role of that agency would be to strategically plan energy development across Scotland, working in partnership with the Public Energy Company, which the Scottish Government has now offered and rejected twice. We are being led to believe that we will get an energy agency. Now, I haven't seen the full details of the plans for this yet, but from what we've heard so far, it appears to be another website or another portal. Not looking too unlike Home Energy Scotland, which is the online delivery front for delivering home energy efficiency. Great if you're a middle-class householder who's very web literate and everything else, or you know, if you don't struggle with calling somebody up over a phone line. Not so great if you're you know, if you're information poor, if your ability to to understand, really understand information is not great. Also not great if English isn't your first language. So yeah, the Scottish Government has just told us that they're not planning to do it. And oh, sorry, I was getting slightly lost. Back on the CEDA. One of the things that we put into that proposal was that we need to create a hub of technical knowledge within the Scottish Government. If you are a civil servant, I know how much the head of the heat networks team gets at the Scottish Government. It is not the sort of money you would get as a middle-ranging, maybe verging on senior consultant for an engineering consultancy. Dear old, I forget back, he's just moved around, but the money they are paying is not going to attract that sort of level of technical expertise across the civil service. But one of the things we sort of shoved into this proposal was using the CEDA as a way of getting a hub of technical skilled people on long-term contracts on appropriate paying conditions, who can serve as a hub to support local authorities and other organisations installing any form of renewable energy. But I mean, the focus of this was really around district heating. We took the most complex low carbon or renewable energy system and thought, right, what are the policies that we would need to deliver this at scale, to the sort of standards and levels of technology that the Danes and the Swedish and the Norwegians and the Dutch are doing. Multi-technology systems using large-scale solar thermal, interseasonal heat storage, and then one or more of a number of other energy technologies. That will include heat recovery, water source heat pumps, any large-scale heat pump, and local and sustainable biomass, with the emphasis on the local and the sustainable. If you look at progress in Denmark, projects developed by Ramboll, who are the world leaders in developing these systems, they are getting 50% plus of their heat demand from solar thermal for district heating systems, critically because of employing interseasonal heat stores. 50% plus for district heating, and the cost they're now getting it down to, which is between about 30 and 50 euros per megawatt hour, is an absolute game changer when it comes to comparing the costs of heat from other technologies. So we've pushed hard on this. We've lobbied the government, not with much success. We have a Heat Networks Act, which is unfit for purpose. We now have the problem of an insufficiently skilled workforce. Again, the Scottish Government's consulted recently on energy efficiency skills for Scotland. And now I'm pleased to say there's some things that were in that consultation that were promising, talking about working with expert organisations and universities, including ours, to deliver the sort of technical training that we will need to decarbonise our economy. We know if we, surveys have been done of workers in the oil and gas sector, that 70% or more of those workers want to get out and want to use the skills that they have to help decarbonise Scotland, decarbonise the UK. And also, if you think about it, if you think about something like decommissioning an oil rig or decommissioning a nuclear power station, the people who design those plants, those rigs, are exactly the sorts of people we need to be getting into the jobs to actually decommission them at their end of their lives. And they've got transferable skills. It shouldn't be too hard to set up, to set up an environment where, if you're in the oil industry and you want to get out and you want to retrain to, I don't know, build wind turbines or build tidal plants or all the many other things that we could be doing, to be able to retrain. Currently, we have Skills Development Scotland, which, if you go onto their website, I'll let you form your own opinions of it. It does not scream to me to be a hub that I would go to advise somebody about how they can find out about how they would be trained in a very, very technical field. It's great if you want to be qualified to be a barista in Costa Coffee. Great, there's loads of courses that are really clearly easily available. A skilled professional retraining in a related field, I think you'd be stuck. It's great that we have the IMechE and the other professional associations who offer CPD, but we need a concerted effort, and that has got to be facilitated by governments, not led by it, facilitated by those of us who work in the sorts of institutions who can deliver this transition. And also, it's not just the people, the technical experts in those organizations, it's all the jobs that they also support as well. If you're, to put it bluntly, if you're a cleaner working for a dodgy oil company, then great, you've got the same skills, you can apply them to cleaning that renewable energy hub down the road. If you're in admin, it doesn't matter what job you're in, we need to get more and more people working for these companies. And then also, we need them to be based in Scotland and paying their taxes back in Scotland, be owned by companies whose registered HQs are in Scotland. If you're on Twitter at the moment, somebody who I've never met, but I've become a great fan of in the last few months, Dick Winchester, every time the Scottish government posts something out about, oh, we need to be training people, we're doing this with renewable energy, or we're opening this wind farm or whatever, Dick jumps in and points out and says, well, it's not actually in Scotland. It's not owned by a Scottish company. They're not paying their taxes back in. We saw that with Bifab, the manufacturer, the wind farm manufacturer, just down the road from me. When Bifab went under, that was a fantastic opportunity for the Scottish government to step in and take that as at least a partly publicly owned company. But no, it's now been bought out by, I gather, a company that will pay most of its taxes in Canada. Great, so there is an awful lot we need to be doing. Oh, move on to questions, right. So I will just throw in very, very quickly the legal right to home working. We've seen the pandemic. Home working is something that all of us should be doing, and the number of people who are attending the COP for all the right reasons, I'm sorry, but a lot of us can be doing our work from home, and this is the way the future is going. The majority of flights are for business travel, and there is no plug and play technology we can be using to decarbonize aircraft right now. So this has got to change, and hopefully the likes of me standing here and hopefully having some interesting interactions are proof that we can do it. And with that, I just quickly end on two very things. What can you do? Join the likes of us, get involved with Commonweal. Feel free to drop me an email. And I have to put in a plug for the Science Oath that's been pushed out by Scientists for Global Responsibility. We scientists, engineers, architects, professionals, we have to be the change that we want to see in the world. And I will leave that there because I didn't realize I was running over time. But thank you very much, and thanks for listening.
Thank you, Keith. Just going to move directly on to the questions we've got here from online. Apologies to Catherine Gruber, we missed your question earlier, but we will move on to that once we've finished with the questions for Keith. So we've got Daphne Wasserman, first of all. Apologies if I've not pronounced that correctly. So most houses and tenements are old with lath and plaster walls, architectural features of interest, etc. How do you improve these homes?
There are a number of ways, and this is always the point where somebody will ask me, what can I do about a particular property? First things first, get a suitably qualified building surveyor in, or somebody with an appropriate architectural qualification. There are a number, but tenements are incredibly energy efficient buildings for their time. I used to live in one. If you know, if you live in a well-maintained tenement, it's a really comfortable, really quite energy efficient property, much more so than the crap that we built in the 1960s. You can go down the passive house route. John Gilbert Architects have retrofitted tenements to passive house standards. It's not cheap. I'm not saying I would advocate it for the majority of tenements, but they can do it if you want to pay for it. But there are a lot of measures, installing, if you haven't got, equivalent double glazing, that's one thing that can go in. There are a lot of companies, very, very small companies tend to be working with natural insulation products. Thermofleece down in Cumbria is a good one, who deal with sheep's wool. But putting just a matter of putting sort of natural products into those buildings, insulation, energy efficiency measures, and that kind of stuff, that will give you arguably as good an outcome as you would get from, inverted commas, modern methods, and actually with a much lower embodied carbon. And I don't think it's necessarily about making all our homes, zero carbon, because that may not be possible with a lot of traditional build. But if we can also tackle the whole life costs as well and bring those properties, to a decent level of energy efficiency, that will get us most of the way. I hope that's a sensible answer.
Thank you, Keith. Our next question online is from Thibault Sam. Thanks for your fascinating presentation, Keith. Could you please share some examples of data which demonstrates how readily behaviour change can have significant impacts on energy management of our homes?
Oh, well, for a start, it depends what you call behaviour change. The Scottish Government currently assumes one-off behaviours like installing insulation are classed as behaviours. I don't personally class them as such. It's obviously opening the door to talking about smart meters. And something I'm rather skeptical of. Another of my fields is electronic waste, and I do view the current rollout of smart meters, the current specification, as probably leading to an awful lot of unnecessary electronic waste. Good for some people, good for people who, for whatever reason, struggle to read their energy meters, partly in some cases because they can be placed in very awkward places. It's difficult to put numbers on it, and as Ian mentioned, you've also got to deal with Jevons paradox and the rebound effect. And I think we probably get too hung up on this, because a lot of the behaviours that we need to be making, the simple stuff like leaving lights off, not leaving lights off in a room, you can quantify the technical elements to a certain extent, but I would struggle even with really quite solid data to say this one behaviour change resulted in X amount of energy consumption, because the stats just, once you get into the numbers, it's really, really difficult to tease out. I think we need to be looking at lifestyle changes, just being more conscious of our energy use. So some of that will be, purchasing more energy efficient appliances and putting insulation in, but doing things that make you more aware of your energy consumption. And the modern, the high-tech smart meters that you can get from the likes of Google are, potentially really quite good. But I've got to be cautious that there is an issue with data, and some people, and myself included, are not 100% comfortable with sharing, potentially very, very granular data. So it's a difficult question to answer, and I don't want to get bogged down in what is it you could be doing, because ultimately I just turn around and say, right, well, okay, well, don't fly, don't drive, and if the question of population and children will inevitably come up, but population is a major driver of global energy consumption. and I'm child-free. I would encourage other people to think about maybe not going child-free, but not having large families in the UK. I'm being quite specific here. So yeah, it's the big stuff, and then how that translates to the small stuff, and so it is a difficult question to answer. I hope that's enough of an answer.
Thank you, Keith. In the interest of balance, do we have any questions from the room? No, none just now. If we have time then for just one more question from the online audience, that's okay.
Yes, thank you, Amy. Keith, thank you very much. That was very interesting and tied in nicely with Ian's presentation and highlighting how behaviour change is a big factor with insulating homes. There's the energy hierarchy perspective of prioritising demand reduction. And then there's the economic side, analysing the whole life cycle costs of embodied energy. But when it comes to the fuel poverty that you were discussing, there are also all kinds of knock-on economic effects associated with fuel poverty, such as ill health potentially, unemployment potentially, and all the consequential costs on society. And do you see any movement in pricing in those external costs when you're looking at energy systems, demand reduction measures? Because it's not just the cost of the energy systems and the electricity and the heating fuel, is it? It's all those other costs we need to be thinking about also.
Yeah, really, thank you. That's a really, really important point to raise, and it is something we have pushed on with Scottish Government, and I'm sorry to say, really not having much success on. Yes, if you are fuel poor, you are more likely to be suffering from physical, mental health issues, amongst others. And fuel poverty has a dose-response relationship. It's one thing we do know. So if you fall into fuel poverty, the further you fall into it and the longer you remain in it, the longer those effects will continue to affect you after you've been lifted out of it. So it is actually, although we can't say, it will, tackling fuel poverty will necessarily save so much to the NHS or bring so much money into a local community, we know that the less we deal with it, the more it's going to cost us. A quick example: if you live in say you're an elderly person and you can only afford to heat your living room, which sadly during the day, which sadly that is the case for a lot of elderly people. You're sat in your living room during the daytime and you get up to go to the toilet, and then you go into a cold bathroom. If you've got COPD or a heart condition or something, that could trigger a feeling in you that says, oh, I need to go and get this checked out. And those multiple contacts with the health service, which don't necessarily need to happen, because if you were walking from one nice warm room into another, it wouldn't set your condition off. Those are costs, and I think we can put numbers on them. The Scottish Government has enough data, hopefully, to do it, but it's just not something it's looking at, because again, there's this focus on fabric first rather than, as we call it, folk first, our approach, and that got us into nature energy. So, there's other people out there agree with us, but the Scottish Government has been historically very, very resistant to doing that. So, yeah, absolutely agree.
Before we hand back to Rupert for some closing remarks, just one last question here. Name of the Inverness Timber Building Company, from an anonymous attendee, Keith.
Sorry, could you repeat that?
Yeah, sure. So yeah, they're looking for the name of the company you mentioned earlier, I think. Oh,
sorry, IMechE in Inverness, M-A-K-A-R, and I can probably find a few more as well. Yeah, based just outside Inverness, fantastic company employing, exactly the sorts of young professional people who will, in some cases, end up in the IMechE or end up in other professional associations. And Neil Sutherland's the director.
Okay, thank you.
Thank you, Andrew. Thank you very much, Keith. That was a fascinating presentation covering a whole range of different topics. I think a lot of questions are raised there that we can't expect to answer in one evening, but big part of this is encouraging people to think about these matters and be aware how significant they are. And another point is that we all suffer often from a lack of data, and the more we can think about collecting the data and using it in the right way, the better. And tomorrow we've got a workshop in the afternoon, which some of you might have already registered for, and if you haven't done, I encourage you to do that. If you're local, that's face to face. It was going to be too difficult to be hybrid, but in that we'll be working through. Ian will be present again, and we'll be working through some of the practical implementation of measures, looking at the links between university and the commercial sector and how they can work together in trying to push through some of the improvements. And we've also got coming up on Thursday another meeting, which is in Quaker Meeting House, engineering climate stability. And then we're going to have three presentations there, including one on transition engineering and the circular economy, looking at agricultural nutrients. So I also encourage you to register for that. Well, thank you very much, everyone, for your for engaging and the good questions tonight. And I hope we'll all go away not necessarily with all the answers, but be on the pathway to thinking of what's required and then putting into place, because we haven't got time to wait. We've got to crack on with this, and so I'll look forward to seeing you again soon, hopefully. Thank you very much, everyone.
Thanks, everyone.